Hello, it's Duncan. Here on the Gilded Rose development team, we are now finally ready to make use of our foray into time zones and number of days between two times in order to complete our work on the stock class. So let's have a look at what we've got here. We've got two tests. One just loads the stock from a file, and the other shows that if the stock was last modified yesterday for some time now, when we ask now, then it's updated. But we're not actually updating the stock at all. All we're doing is showing that we save the stock list with a new last modified time. And the code is here. You can see all we do is we ask how many days there are from the time in the file to the time when we ask the question, which we pass in as a parameter. And if it's not 0, then we resave the file with the new last modified. Okay, so first thing about this test is that it's hard to see what stock list we're using. We're using the standard stock list, but if we're going to make changes to that, it would be nice to be able to see it in this code. So maybe we'll just inline that so we can see what we're making use of. And obviously there's no point in calling the constructor and then making a copy, so we'll just pull that up there like that. And that should make no difference to this test, but it'll let us see what we are doing in this test. All right, so what sort of change do we want to make? Thinking back to our requirement, our customer said that this is going to be complicated, but at the moment they're happy for us just to reduce the quality of each item by 1 every day. So let's think how to express that. So we'll write a function here that expresses how to update a stock list that way. This will be a function, and it will be update, and it will take a list of items, and a number of days. And we want that to subtract 1 quality for each item every day. So that's going to be items.map it, and we're going to copy each item and replace it with an item whose quality is the quality of the item minus the number of days. And we have a small problem here that quality is a uint and we can't subtract an int from a uint. So I think it was a mistake to choose uint, to be honest with you, but for now we will just convert in here and worry about that a little bit later. So that's the way we'd like to update our items, and if we did update our items that way, then the expected updated result would be this initial stock list. Well, let's inline that again so we can see what it looks like. And again, we will just change that to be now. And what we expect the updated stock list to be is one where each one of these qualities is reduced by 1. So that would be 41, and that will be 100. Okay, if we run that, obviously the test won't pass because we haven't added any code. And before we go on, I think let's just move this stock out into its own file, but we'll leave it in the tests so that nobody's tempted to use it in production code until we're finished. So let's do that, add that to Git, and then go and find our stock. And we'll put that over there so we can see them both at once. Okay, so the test failed that we expected because we haven't subtracted anything from the quality of these items. Okay, we want this update to be a strategy. We could hard code this into our stock here, but our stock class is probably going to have enough to do working out whether to update the stock without worrying about how to update the stock. So what we're going to say is let's pass this strategy into our stock class, and we'll express that here by saying let's add the names of these call arguments, put them on separate lines, and then we'll add an argument for how we update. And that update we want to be able to pass this function into. Bit confusing, we'll call it update items here. Now in IntelliJ you can see we don't have one of those, so it will allow us to create one. Unfortunately, it won't give us a nice function type. We get this silly Kotlin reflect function, k function 2. That hasn't been fixed for years. But a k function 2 takes, these are the two parameters, and this is the return type. So we can replace this with the first bracket, and this is the second parameter, and then this is the return type. And to make things a bit clearer, we can actually name these parameters. So we could name these items and this days. Now, that will compile, if not actually pass the tests. But we should be able to make it pass the test by using this update function. So in order to use the update function, we're going to have to remember how many days there were. And this is days out of date. And if it is days out of date, then we want to copy the loaded, changing not only its last modified, but also its items. I'm going to take those items and apply our update to them. Making this a val. Telling it how many days we're out of date. And again, we have a small problem of needing an int in here because we started with a long. I think the chances of us running out of an int in the number of days we're out of date are pretty slim. So we'll run the tests. Compiler seems very slow today. And that passes. Thinking this through, we haven't really checked that we've passed in the correct number of days, so we could also write another test which shows update stock by 2 days if last modified the day before yesterday. The day before yesterday would mean that we had to advance now by 1 day compared to yesterday, and we would expect the result to be a quality of 40 and 99. So let's check that. Good. Thinking through the whole uint thing, we should also think what to do if we end up loading a file that turns out to be an updated after now. In fact, after today. That could happen if we looked just before midnight and some other thread was coming in and modifying it. I think the same thing to do there is to simply do nothing. And so let's write a test that shows that that's what we do. And we'll say, oh, dearie me, does not update modified tomorrow. So our expected result is then our initial stock list. And that would happen if we called this the day before the stock list had been modified. So this last modified was the 9th, so we might go to the 8th. This is now not there. If we run this, we might expect this to fail because they're updating over here simply if it isn't 0. So we should probably reverse the sense of this and change this to be greater than 0. And in which case I'm tempted to make this a when condition because it looks a bit nicer. Good. Okay, I just had to restart IntelliJ because it's using all of my processor for some reason. Okay, so it feels like we're almost there. Just one last thing to do really, and that's to check that this works well if stock is being accessed on multiple threads, because we're accessing this from a web server and multiple jobs can come in and read the stock file. And they could try and update it. So we'll write a test that shows that that is safe. And I think what we'll do is we will write a test and call it fun execution or something like that. And we'll make use of the test that we already have, maybe this update stock if last modified yesterday. So we could call that. What we're going to do is we're going to call that in parallel. So we will set up an executor service, and we'll ask for a thread pool executor, fixed thread pool, and let's go with 8 threads in that pool. In fact, let's remember that number. So we can run 8 things in parallel, and now we will build a number of jobs and we'll submit them to that executor. So we can say invoke all, and the task we will take by between 0 to 8, and each one of those we will map into a callable where that callable will call this function in that, and then reformat so we can see what we're doing. So basically we're going to run 8 times in parallel this test. And we want to check the results. We want to make sure they're all back before we finish the test. So these will be a bunch of futures. And we can take each one of those futures, and get the result from it. And if any of these were to fail, if these were to throw, which is to say they weren't right, then this get will throw and we will see a failure of the test. So let's just run that. And that passes nicely. I'm always a bit suspicious of tests like this though, because we don't really know that they are all hitting this code at the same time, and we want to make sure that's true. So what I'm going to do is I'm going to make them all stop before they start. And we can do that with a cyclic barrier. And the cyclic barrier will allow the number of things that we've got to reach it, and then it will make them all wait, and then they will all be allowed through. So at this point we can say barrier.await, and they will all then try and call this almost immediately. All those threads will be let through this gate. Now I obviously have a problem here because we're not continuing. Why is that? I must have this off by 1. So let's try printing how many of these things we have. Rerun this test, and you can see that we have 9 things, 0 to 8. So we'll change that back to 1, rerun, and now a test pass. So we can take that out. So that's quite a nice demonstration that things are working as we expect. And we'll have just one final sanity check. Let's run that parallel execution a few times itself. So we'll call this sanity check. And we'll run that test. And that passes. So, all good to go. Just run all of our tests in stock tests. And this fails. Now, I can't lie to you. I have been through this once already, and this is pretty much exactly what happened to me. Everything looked absolutely fine. I can run individual tests all by themselves. I can run this test all by itself. That's fine. But when I run all the tests, they fail. And it took me quite a time to work out what was going on. And the clue here really is you see what we actually get out of here is a stock list with the last modified of 1170. That's the epoch. And the time we put that in the stock list is if we load a stock list from an empty file. And what I think is happening here is that in certain circumstances, we can enter this on several threads. And when we start saving this to the file, the first thing that happens is we create an empty file before we start writing items to it. And another thread can come in and load that empty file. See that change, and it will then return an empty stock list. Okay, how do we solve that problem? Well, one thing we could do would be to simply synchronize over all of this. Now, we don't see synchronize much in Kotlin, but it is there. We can say synchronized, and we could take a lock on this object. And then we could run all that code. We can't mark a function as synchronized, but we can take a lock and run a block. Let's run that. And it passes, which gives us some confidence, but with concurrency problems, we probably need to run the test quite a few times to be totally sure, but gaining confidence that that works. Is this a good solution to our problem? It might do. The problem is, though, that this only works within one JVM because we can only synchronize an object here. And maybe we'd like to be able to run more than one copy of this web server as Gilded Rose goes global. Or maybe, we'd just like to solve this in a better way, learn something from it. So let's back this code out and think of how we might approach this in a better way. Check the test file. And the tests do fail. So, doing a little bit of research, it turns out that we might be able to lock files in Unix-like operating systems, but it very much depends on processes cooperating over locking files, and I don't know how to do that with Java file APIs. It might be possible, but I think maybe what we're going to try doing is one thing that I know is atomic in file systems, and that's renaming a file. So we could probably solve this problem by writing to a temporary file and then moving that temporary file into the place that we want it. And it won't matter if lots of our threads are writing temporary files and moving them, because they will all be the same updated temporary file. The contents of it will be the same. They may differ very slightly with respect to when they do it, but they will all updated in the same way if we get this right. So let's think about how that might work. One of the things I think I'm going to do is separate out the determination of the file that we want to write, the determination of the contents of the file we want to write, from writing it. At the moment we've got this also here, which is a bit strange. So what I'm going to do is I'm going to say the thing that we're going to save will determine with one statement, one expression, and that's going to be, well, let's make that into this. So this is updated stock list. It may be potentially updated stock list. Let's be explicit. And then we'll not save that here. And here we'll say if the potentially updated stock list, last modified, is not equal to the loaded last modified, then we'll save. Then we know it has been updated, so we can say save to our stock file. And that's just really separated out some calculations from some actions. If you read our book, you'll see that we talk about actions and calculations, where actions depend on when you run them and calculations are always the same. And this expression will always give the same result, and allows us to reason with our code a bit better. Of course, we're doing some work that we need not have to do in this comparison, but it's not a great deal of work. So now what I think we'll do is we'll pull this out into a method, because it's going to get bigger, going to get more complicated. And we'll call this save. And the name of this parameter is now just stock list. Okay, so what did we say we were going to do? We said we were going to create a temporary file. And we can go to File and say Create Temp File. For now, we can give this any old prefix, and we can give it any old suffix, but we might as well use the suffix from our stock file so that we keep the name of that. So this is stockfile dot. It's a Kotlin extension called extension. And I happen to know that this doesn't include the dot, but this doesn't add a dot. So we'll put the dot in here. Not that it's important at the moment. So now we're going to save to our temp file. And then we are going to take our temp file and move it, rename it in Linux speak, to be our stock file. Does that solve our problem? Well, it seems to, but we'll only be convinced by running this a few times. In fact, we can only ever be really convinced by never seeing it fail. This rename can actually fail in Java. It returns a Boolean, and if it did, we'd be in trouble. So let's say that would be a failure of our logic. I'm going to say, so we're going to say, if that ever fails, that's an error. If we see this happening, we might want better diagnostics than that, but that will do for now, because we don't really expect it to happen. Okay, so now we have a version of our code that works, at least as far as we've tested it, across multiple threads. I'm not sure how much confidence we have. I'm getting more confident, certainly. But we might be tempted to put in some logging at this point to save us if things go wrong. But I have a better idea, and that's to make a virtue out of this temp file. So my plan is to save every version of the file that we ever save, to keep every version of the file we ever save. And so what we're going to do is we're going to create a file with a name that makes some sense to us. And so my feeling is something like val, maybe version file. And we are going to create a temp file. And the prefix we're going to use is the name of our stock file. And we're going to put in the name of our stock file. Without its extension. Another Kotlin extension. We'll put in a dash and let's put in the time that we were saving it. In which case we're going to need now, which we don't have, but we can get by adding an instant to here and passing it in here. So our prefix will be that. And our suffix will be whatever the suffix was we were using before, which is this dot plus stock file extension. And we will save that in the current directory of the stock file, which is another parameter to create temp file. So that is stock file dot parent file. And here you see we'd like there to be some name parameters, but this is a Java API, and so we don't have access to parameter names. So what should we do? Well, we'll save, in fact, to this version file. And then we'll save both to this version file and to the temp file. Now we could either copy the version file into the temp file, but we know that saving is idempotent. It's always going to be the same result, so maybe just save twice. Okay, IntelliJ also seems to have crashed again. And let's run this. That should give the same behavior. And now let's have a look at what files we're creating. What I'm going to do first of all is I'm going to print out the stock file. So we know where we're putting these things. Let's just run that because these are going to go in a temp directory. And you see these are all in the same directory. So we'll change into this directory. And then we will say find files with the name beginning with stock with a max depth of 1. And you can see that we have the stock files that we've saved, and then we've got these backup files which have the same root as the stock file but have the date stamp and then some random temp file digits. Might be a bit clearer if we pipe that into sort. There we go. Let's just clear them out and see what happens when we run a test. So we can do that. Delete all those, check that there aren't any, and now we will run our parallel execution run and see what's in our directory. And that's pretty much what we expect. We have the stock file. It's got this weird name from our fixture to differentiate it from all the others, from all the other tests that we might run. And here are all the backups, and there's 1, 2, 3, 4, 5, 6, 7, 8 for our 8 threads. So every time we save the file, we will keep a backup of it, and that should bail us out of any holes that we might find ourselves in if we've messed up this concurrency. Okay, let's just have a little tidy up. We can take this out of here, and now we'll rerun all of our tests to check that everything's happy. That's all good. Incident days 2 is still stuck in our test, which is not a good place for it. So let's move that over here. And we'll just have a little look at our test, see that it is communicating everything it could. I think this could reasonably be private. Starting at the top, we're saying we've got an initial stock list and a fixture based on that initial stock list, and then we've got the class under test, which is our stock. And then we're loading from a file. We're showing that it's updated if it was modified yesterday. We're showing that happens in 2 days. And we're showing it doesn't happen if we look back in time, effectively. And then we've got our parallel execution test we just look at. These are the sort of things that I probably want to come back to tomorrow with a fresh eye, because this has been tiring. One unused import, it turns out. So we're not going to push this to production. We'll leave it here in our test tree. Come back tomorrow and have a look and just sanity check what we've done. Now, you might ask why we've been messing around with files here rather than using a database. And partly the reason is because I'm not very good at databases, and I am quite good with files. But also because using a database wouldn't really solve our concurrency problems here. We'd still need to update something in an atomic way. And if we were to update something in an atomic way, and we were using some database abstraction, which makes using SQL a lot easier generally, we'd still have to find a way through that in order to select for update or some SQL magic that would allow us an update in an atomic way. At least this way, our fate is in our own hands, and we can reason with our code rather than having to test our database. I'm not sure that's a very strong argument, but we are where we are, and I think we have a working system, but, well, we'll look at it with fresh eyes tomorrow. Let's commit this. Stock now updates file on disk, that's good. Commit that. And I think we're done for the day. This has probably been a long episode by the time it's edited. I hope you've enjoyed it. If you have, then you could subscribe in order to hear about the next one as soon as it arrives. And if you enjoyed this, you'll probably enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook. In that book, we talk a lot about the differences between calculations and actions that we spelled out here in stock when we did some calculations before we saved the file. Details of the book are in the description below. Thank you very much for watching.